So today is the 23rd, huh? 1/23/19. So our objective, here's what we're going to do today. We are going to be translating parent functions. Okay, what does that mean in English? Translating parent functions. What does that mean in English? It means this. We're going to be moving our basic graphs. So when I say parent function, I'm talking about, like the regular x squared. And we moved that around, didn't we? We might also move the absolute value graph. We might also move the square root graph. So what you have in your first notes are all those parent functions, right? So let's take a look. So first of all, example 1. This is the parent function. The same thing as y equals 1. That's my parent function, okay? Y equals 1 is my parent function for my horizontal graph, or it's called my constant function. That's the name of it. It's called the constant function because it stays constant. It's always going to be 1. Does that word make sense? It's a constant function because it always stays 1. So we know that the parent function looks like this. There's f of x. And then we want to make g of x, which is a translation. We're just going to move it down, okay? So g of x is down 1, 2, 3. And there's g of x. Okay? So when I say describe, tell me in words what happened. What happened from blue to red? Words. Give me words. I just moved it, didn't I? Moved it down. So we could say that it was, I'm going to say translated 1, 2, 3, 4 units down. Okay? Yeah.
When translated, do you mean put another graph on it?
No, translate means just moved. Just take the graph and move it around. Like we did here with all of our x squareds. I moved it. That's called a translation. I moved it. Okay? All right. So let's look at number 2. So our parent function, this is my parent function. Y equals x is my parent function. And if I have to graph this, my parent function looks like up 1 over 1. Everybody agree? Start at 0. Up 1 over 1, right? Everybody agree with that? Because it's really a y equals a 1 over 1 x plus 0, but that's all the extra numbers that I don't normally need. Everybody agree with that? Now, if I'm going to graph 2x minus 4. Now that's easy to graph. 1, 2, 3, 4. All right. I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. Okay. And, They will, but we don't care about that. But great, you're right, Daisy. Totally correct, yeah. And at some point in time, we will care about that. Good observation. They will intersect. Actually, they intersect at 1, 2, 3, 4. 1, 4, 4, right? Yeah, good job. So in words, what happened from blue to red? What happened? If I took blue and changed it to the red, what happened? So blue then becomes red. What happened? Okay, the slope increased by how much? 2. So it has a vertical stretch of 2. And what else, Rory?
It translated down 4.
Beautiful word. My gosh, I couldn't have said it better. Translated. Love it. Translated down 4. Awesome. You guys agree? Nice word. Okay. Easy so far? Now, last semester, first time through this book, I should have taught this better. This semester, I'm doing a great job because this is on your test or your quiz coming up next week, and you guys know exactly what I want. Parent function, and then the new graph, right? And then tell me what's going on. Turn the page. All right, absolute value graph. So that's my parent function. If I have a y equals an absolute value graph, and we saw that. We saw that on our graphics calculus. The v it looks like this, right? Okay, that's my parent function. And then if we're going to take and change it to absolute value of x plus 2 minus 3, what I think is the easiest thing to do on this one is just find its vertex. So the vertex is the pointy, right? So the vertex on this one is going to be at negative 2, 3. Opposite, remember? Opposite, because it's the negative 2 that zeroes it out, which gets us to the lowest point, which is the vertex. Yes?
How'd you get that V-shaped?
Real quick, one more time. Absolute value means anything that goes in stays positive. So if I go over negative 1, absolute value of negative 1 is a positive 1. Negative 2, absolute value of negative 2 is a positive 2. Does that make sense? And so all of these numbers here have to become positive so they shift up in the graph. Yeah, and that's how it works. Okay, so let's take this blue graph and let's move it to negative 2, positive 3. 1, 2, 3. So it sits right here as the vertex. And we're going to take this exact same shape and just move it. That's all we're going to do. Take this shape and move it so it looks like that. Okay. How am I doing? So give me description. What happened? Yes, Daisy.
It transfers up 3 units and left 2 units.
Units and to the left 2 units. Well said. Well said. Awesome.
I don't get the negative thing going. Why is it negative 2?
Okay, one more time. So the vertex, the V, right here, that's the lowest spot, right? Isn't that the lowest spot? There's nothing lower than that, okay? What number here, what number right here would make this zero out so I get the lowest? It'd be negative 2, wouldn't it? Because negative 2 plus 2 is 0, which would give us my lowest spot in my vertex. That's why it's the opposite, because this number has to zero it out to bring it down to its lowest spot. Okay? All right, example 4. There always, right, Cole? There's always a reason. There's always a reason, a real reason. And you guys are so lucky you got this old guy who's been teaching forever. I happen to know every reason in the world, right? So anyway, parent function, right? We know this one, y equals x squared. Morgan said that's that parabola, right, Morgan?
Yeah.
So I'm going to go, watch. Over 1 squared is 1. Over 2, 2 squared is 4. 1, 2, 3, 4. And I'm squaring numbers because it's x squared. 3 squared is 9. It's probably off my paper, but there it is, okay? I know negative squareds are positive. Negative numbers squared are always positive. Negative 1 squared is 1. Negative 2 squared is a positive 4. Negative 3 squared is a positive 9. Plus it's symmetrical, right? And there's my parabola, okay? Easy? All right? How am I doing? Now, what am I going to do? Well, where's this one going to be? Up 4, perfect. What about this negative, though?
Upside down.
Yes, that's totally right. So this one's going to be upside down. Or we could say it's a reflection over the x-axis. Fancy words, but I'm going to say that, okay? But upside down is okay for right now. I like that. 1, 2, 3, 4. And I'm still going to do the 1, 1, but it's upside down. 2, 1, 2, 3, 4. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's symmetrical. And there it is. Nice job. So when I use my description, I'm going to say what Daisy said first. I'm going to translate up 4, and then we're going to reflect over the x-axis. Okay? Does that make sense? Yeah, Ashley.
Does it matter if you say reflect first and then translate?
I like that. Technically, I would have said it the other way around. I really would have. I would have said reflect first and then move it up, because it makes more sense that you reflect it first and then shift it up. Yep. In fact, that's the way I would have said it, but I wasn't going to get too technical right now. I completely agree, because you really do flip it first and then move it up. Thank you. It's completely correct. Okay, let's check out our journals. Okay, let's see what it's all about. So let's find our journals. Let's go to page 26 and see what the journal's all about. Okay. So the journal really is a really great access to